Imagine you're in a bumper car arena, except the cars are moving at 17,500 miles per hour. You can't see them. And if one hits you, it's not just game over, it's lights out for billions of dollars worth of technology. This isn't a scene from a futuristic sci-fi film. It's happening right now, high above our heads. Welcome to the wild world of space debris, where our cosmic litter is threatening to turn the final frontier into a giant, deadly junkyard. Buckle up, because this ride isn't just bumpy, it's dangerous. The menace above. Why space debris is a growing problem. Space debris isn't just an abstract concept, it's a real and present danger to the future of space exploration. These bits of junk, ranging from entire defunct satellites to mere fragments of paint, can move at speeds of up to 17,500 miles per hour, 28,000 kilometers per hour. At those speeds, even a collision with a small object can cause significant damage to spacecraft or satellites. The problem is exacerbated by the fact that debris isn't just created by defunct satellites. Even tiny collisions can generate hundreds or thousands of new fragments, which only increase the hazard. With more than 10,000 satellites projected to be launched by the end of this decade, the risk posed by space debris is only going to escalate. The Kessler syndrome. A chain reaction waiting to happen. Imagine a scenario where space debris creates more space debris until certain orbits become unusable for decades. That's the nightmare of the Kessler syndrome, which NASA scientist Donald Kessler first described in 1978. It's like a never-ending game of cosmic pinball, where each collision generates more obstacles, eventually making key orbital paths too dangerous for human or robotic missions. The stakes are high, particularly for low Earth orbit, which houses everything from weather satellites to communication networks. The terrifying part is that once the Kessler syndrome begins, it may be impossible to stop. Houston, we have a debris problem. High-risk areas. Low Earth orbit might sound like the Wild West of space, and in many ways, it is. This region, typically defined as the area between 160 and 2,000 kilometers above Earth, is home to the highest concentration of space debris, particularly at altitudes between 750 and 1,000 kilometers. This is where the most critical satellites for communications, Earth observation, and scientific research reside, which makes it ground zero for potential collisions. The costs aren't just financial, they're also operational. Each collision avoidance maneuver can burn precious fuel and shorten a satellite's operational life, increasing long-term costs for satellite operators. Space traffic in these regions is so congested that it's becoming almost routine for satellite operators to change orbits just to avoid catastrophic collisions. Mitigation efforts. Prevention is better than cure. While prevention might not be as exciting as a dramatic space battle, it's the most effective tool we have against space debris. Mitigation efforts focus on reducing the risk of debris generation during a satellite's operational lifetime and ensuring its safe disposal at the end. Guidelines like the widely accepted 25-year rule dictate that satellites should be removed from orbit within 25 years of their mission's completion. However, this timeline is being scrutinized, with calls to reduce it to 5 years. This kind of urgency reflects the growing understanding that space debris isn't just a problem for future generations. It's a crisis happening right now. These rules are being enforced more strictly, particularly as commercial satellite constellations grow exponentially. The Zero Debris Approach, a cleaner, safer future. European Space Agency ambitious Zero Debris Approach isn't just about preventing new debris, but also setting a timeline to stop all debris generation by 2030. This initiative is setting new industry standards that could reshape how future space missions are planned, from improving satellite design to incorporating passivation systems, which prevent onboard explosions after a satellite's mission ends. European Space Agency is leading a charge toward a cleaner and more sustainable space environment. The agency is also fostering collaboration through initiatives like the Zero Debris Charter, which has been signed by over 100 commercial and non-commercial entities worldwide. If successful, this approach could become the benchmark for space sustainability across the globe. Active debris removal. The space janitors we didn't know we needed. Preventing new debris is crucial, but what about the junk already up there? This is where active debris removal comes into play. Think of it as a cleanup crew for space, a cosmic janitor service designed to rid space of dangerous debris. Several intriguing technologies are being explored, such as space tugs that can grab and move defunct satellites, or even lasers that can push debris into lower orbits to burn up in the atmosphere. ESA's Clear Space One mission, slated for 2025, will be the first to attempt this on a large scale by removing a discarded rocket part from orbit. If successful, this mission could set the stage for more extensive debris removal campaigns, cleaning up the mess we've left behind. The cost of cleanup. Space janitors don't work for free. Active debris removal sounds great in theory, but the reality is far more complex and costly. Active debris removal missions require advanced technology, careful planning, and precise execution, all of which come with a hefty price tag. And that's not the only challenge. There's also the risk of creating even more debris during the removal process itself. It's a bit like trying to sweep up glass shards without cutting yourself in the process. Despite these hurdles, the growing threat of space debris means that investing in ADR technologies is becoming a necessity rather than a luxury. Future missions will need to balance cost, risk, and reward as they grapple with the complex task of space cleanup. The legal frontier. Who owns the junk? As if the technical and financial challenges weren't enough, space debris also raises significant legal questions. Who is responsible for removing a piece of debris? What happens if one nation's debris causes damage to another spacecraft? The current legal framework is murky at best, with few established norms regarding liability or the right to remove debris. Moreover, much of the debris in orbit was created decades ago, meaning that ownership or responsibility can be hard to trace. International treaties like the Outer Space Treaty of 1967 provide some guidance, but they weren't designed with the current scale of space activity in mind. As space becomes more congested, international cooperation will be crucial to creating a legal framework that addresses these challenges. Protecting future missions, a shared responsibility. The problem of space debris is one that no single nation or company can solve alone. Protecting future missions requires a collaborative effort from both governments and private entities across the globe. This means not only adhering to mitigation guidelines, but also investing in new technologies and sharing data to improve space traffic management. Organizations like the United Nations Committee on the Peaceful Uses of Outer Space are working to develop international guidelines, but the real challenge will be ensuring that all spacefaring entities, including commercial companies, comply. The future of space exploration depends on our collective ability to manage and protect this shared resource. Thanks for joining me on this deep dive into the wild world of space debris. If you found this video informative and want to stay updated on more space exploration topics, hit that like button, subscribe to the channel, and don't forget to turn on notifications so you never miss a new upload. Stay curious and see you in the next video.